Respected sir and dear colleague friends, my name is Deepak Parmar and today's presentation topic is jet propulsion theory. Before I start with this jet propulsion theory, I would like to ask one question, that how many of you are having experience traveling by aeroplane? 1, 2, okay. So how aeroplane flies and how propulsion happens, that is what my topic. So being an engineer, we should understand that any instrument, how it works, right? So my concentration is on that. So objective of this presentation is student will be understand that principle on which engine works and a propulsion theory. If I go specific, define different forces acting on aeroplane and basic design of aeroplane engine. Newton, the great gentleman. The principle of jet propulsion based on two laws, that is second law of Newton's motion and third law of Newton's motion. As we all know, second law of Newton's motion says that rate of change of momentum is proportional to force. So momentum is defined by mass into velocity, that is called momentum. And if we write rate of change of momentum, we can write this way, that is proportional to the force. So as mass is a constant quantity, we can write this way, it is a dv by dt is proportional to force. So we can write that dv upon dt is acceleration, that is proportional to the force. So whenever there is a change in a momentum happens, it will create one force. That is what second law. Now third law says that everybody knows that every action has equal and opposite reaction. So whatever force is generated over here, it will create action. And in a reactive direction, in opposite direction, there will be a reactive force which will propel the aeroplane. So how this propulsion will happen? Momentum imparted to a mass of fluid in such a manner that reaction of an imparted momentum gives a propulsive force. The explanation is right on board. Now you can see this figure, and we have observed this in our childhood, that if you have a balloon filled with air and if you throw into air or if you open the knob, the compressed air will come outside. So it will create some action. So reactive force, you will understand that the balloon will move in a forward direction. That is what principle aeroplane works on, and that is called the thrust force. The force dimension we can write is mass into velocity. Third law of equal and opposite direction, action and reaction, that is known to us. Now let us start with the history of aeroplane. It is 1903. Wright brothers had first flight was taken place in 1903, and they were Wright brothers who have made this flight. You can see that engine is only 12 HP horsepower, that is known to us. Only 12 HP IC engine, it is internal combustion engine used for aeroplane. Nowadays no engine is using IC engine. Nowadays gas turbine engines are used. We will discuss that way. And it was a reciprocating and radial type of engine. Now if aeroplane has to fly, it should be lifted up from the ground. So you and me cannot fly because of weight. So that is what one force acting on that is a gravity. So gravity acts vertically downward direction. So if you want to lift it up from the ground surface, you should have an opposite direction force. It will be equal to gravity, then you can sustain your stable flight at certain height. And as you know that aeroplane normally flies at 10 km above from ground surface. So, and if you take the example of Airbus 380, around 400 passengers can travel into that. Double decker aeroplane. So 400 passenger, cargo, fuel, if you calculate all the weight, that is acting vertically downward direction. So there should be opposite direction force, that is the lift, which will make aeroplane move up direction. So two forces. Second is thrust and drag. Drag force, aerodynamics, if now normally we are using like that. If you have a car, it is having aerodynamic phase. But if you take the example of bus, it is having flat front. So drag force is a opposite direction force. If your bus is moving in this direction, if it is having a flat surface like that, the air will resist its motion. That is called drag force. So aeroplane having same drag force acting on that. So you should nullify that drag force. That should be opposite direction force so that your aeroplane can sustain its steady flight. So your thrust should have a equal or more than that value to propel in a forward direction. So let us understand that how this force is acting and what will be the useful of that. So lift is a major portion or force which is useful, and for that we have an aeroplane wing. I don't know whether you have observed or not, but your aeroplane wing having this kind of wings, and two side here, one is engine over here, second is engine. It is according to engine type. So this is the wings which will lift your aeroplane. So how it will lift, that is what, one simple example if I take, suppose you have a road, straight road, and traffic isn't moving in this direction. Suppose you have one obstacle over here, suppose bus which is stopped here, and you are moving in this direction. Normally we people follow that. If we sense that there is somewhere there is an obstacle, if you are traveling in this direction, automatically you will move in this direction. Agree? Nobody will move in this direction. It will go to this way, this way, this way. Agree or not? Automatically our mind will sense that there is something obstacle, we will follow this path. Same way you can see here, you have a wing, airflow, and this is the shape. You can say it's obstacle to this air. No? So now air will flow in this direction. When air is moving in this direction, its velocity will increase. And as velocity will increase, Bernoulli's theorem says that pressure will decrease. So here the pressure will be less, here the pressure will be high. So pressure gradient. And as you know that normal theory pressure gradient, higher to lower side. So bottom side pressure is more, here pressure is less. So it will lift your aeroplane. So design is such that your aeroplane will be lifted up. So lift is an aerodynamic, now definition of lift. Lift is an aerodynamic force. It must exceed the weight of flight to go up, generated by the motion of aircraft through air, and created by the effect of airflow passing through wing. I have already explained. Now aircraft lift acts through a single point called the center of pressure. So this force, where it should act at the center of pressure. So your design should be such that it will be at particular point. Weight is not constant. Why not constant? Because it carries passengers, cargo, fuel load. Now passengers weight is constant, but as it goes up, gravitational acceleration value, g value varies, so that will vary, and fuel, it will consume fuel, so weight of fuel will decrease. So decreases fuel is consumed or payload decreases. No? Now direction is constant towards Earth center and may be assumed concentrated at the center of gravity. So pressure is acting on center of pressure and weight is acting from center of gravity. Thrust force, to nullify the effect of drag, the forward acting force opposes the drag. Direction of thrust depends on the design. It should be in a forward direction. The propulsion system produce thrust. The propulsion system engine will discuss later on, and equal to drag in a straight constant flight speed. So if drag and thrust is constant, your aeroplane can maintain the constant speed. You can say the inertia, law of inertia, first law of Newton's motion. And equation of thrust is mass of air passing from engine, V2 and V1. V2 is a velocity of gas coming from the nozzle of engine, and V1 is inlet velocity. Its unit is a force, Newton. Drag, aerodynamic force, resistance toward the motion, already explains. Now, if you classify the drag, there are two drags. One is a parasite drag and induced drag. Parasite drag created by the airplane design, body itself, and byproduct of lift generation. If you want to generate the lift, if an aeroplane starts, the wing move in a downward direction, and you can observe this one. Whenever you are traveling on a bike, suppose your bike speed is 70-80 km per hour, if you can put your hand like this, you will feel some drag force. If you put your hand like this, it will move in opposite direction, drag force is acting. But if you give some inclination to that, your hand will move in upward direction. That is what lift is. So acts through the center of pressure again. So drag also acts on a center of pressure. This is what overall idea, force is acting on your aeroplane. Now classification. You can see that previously we were using one-seater, two-seater engine with front big blades, you can say that. So two type of engine we are discussing. One is air breathing engine and second is a non-air breathing engine, or you can call it as a rocket engine. Air breathing engines means the engine is taking air from atmosphere, while in case of rocket you need to provide oxygen tank with that, so there is no inlet of air from atmosphere. Air breathing engines nowadays: turbojet, turbofan, turboprop, turbojet with afterburner, and ramjet. All commercial aeroplanes are using turbofan engine nowadays. Turbojet and ramjet can be used for missiles also. So this is the figure. You can say turboprop engine with large blade in the front. Turbojet, turbofan, the difference is this fan added over here to make more propulsive force. Then intermittent combustion system, pulse jet, it is again one kind of engine. No commercial aeroplane is using that. And second is a rocket engine. In that you can have two propellant, liquid propellant and solid propellant. Now engine, how it works. These are the two engines. You can see this figure. This is what small engine carries 400 passenger weight. Component of that engine is fan. It will suck air in. Second is a compressor. It will compress, so pressure will increase. Then there is a combustion chamber where combustion takes place. Pressure, temperature will increase. The high pressure, high temperature will expand into turbine, which will run this compressor, and then finally it will expand through nozzle. As we all know, the function of nozzle is to increase the velocity at the cost of pressure. After passing through this nozzle, high velocity air will come out that will create thrust and a forward direction. This is the video. You can see that this is the fan, in which blue colors fresh air. Then it will compress into this. In combustion chamber, combustion happens. Then red color hot gases will expand through nozzle and it will create the force. So this is how your engine works. One video will give you the justification how aeroplane works. First, aeroplane takes runway because it requires some momentum. Then it will be lifted up. See, this is the lift. The wing position will be changed. It will be lifted up. This is called takeoff. And how it lands. See. So this engine will give second law and third law principle, and force is acting on that. It will be created by this wing: lift, drag, gravity and thrust force. Any question if you have? Just.
This airplane is Airbus 380. So which type of engine in that?
Turbofan engine. I explained. Turbofan engine. Okay, thank you.